Good morning, friends. In the last lecture, we have seen the new article, that is Jacobian. So we have defined the Jacobian. Jacobian is if u is a function of xy and v is a function of xy, then Jacobian of uv with respect to xy is nothing but the determinant ux, uy, vx, vy. Then we have seen some properties of Jacobian, that is j into j dash is equal to 1. That is the important property. And also we have seen examples on Jacobian. So continuing with the same, we will see some more examples in this lecture on Jacobians. So the example is, if x is equal to u square minus v square and y is equal to 2uv, find jxy by uv, means Jacobian of xy with respect to uv. So Jacobian of xy with respect to uv you can directly write in terms of determinant by definition of Jacobian: dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So what is dou x by dou u? That is 2u. Dou x by dou v minus 2v. Dou y by dou u 2v. And dou y by dou v 2u. So this is the determinant. So 4u square plus 4v square, that is 4 times u square plus v square is the value. Next example, if u equal to x plus y upon 1 minus xy and v equal to tan inverse x plus tan inverse y, find Jacobian of uv with respect to xy. Jacobian either we write like this or we write like this. So here Jacobian of uv with respect to xy is again ux, uy, vx, vy. So u, what is u? U is x plus y upon 1 minus xy. So to differentiate this partially with respect to x, we use quotient rule. So by quotient rule, denominator into derivative of numerator, that is 1, minus numerator into derivative of denominator. So derivative of denominator is minus y divided by denominator square. Similarly, dou u by dou y, again we use quotient rule, and by quotient rule 1 minus xy minus x plus y into minus x divided by 1 minus xy bracket square. Then vx, vy. Vx means v is like this. So dou v by dou x means vx, that is 1 upon 1 plus x square plus 0. And dou v by dou y 0 plus 1 upon 1 plus y square. So you just cross multiply this and see it is 0. It is just the part of multiplication, subtraction, etc. So you can do the details. You can add some more steps. Next example is, if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta, show that Jacobian of xyz with respect to r theta phi is equal to r square sin theta. So here x is this one. So dou x by dou r is sin theta cos phi. Dou x by dou theta is r cos theta cos phi. And dou x by dou phi is minus r sin theta sin phi. Derivative of cos phi is minus sin phi. And therefore this one. I suppose you understood all these things. Dou x by dou r. So sin theta cos phi is constant. Derivative of r with respect to r is 1. And therefore sin theta cos phi is the answer for dou x by dou r. Similarly, dou x by dou theta. So r and cos phi is constant. Derivative of sin theta is cos theta. So r cos theta cos phi. And dou x by dou phi is minus r sin theta sin phi. Similarly, dou y by dou r is, y is this one. Dou y by dou r is sin theta sin phi. Dou y by dou theta is r cos theta sin phi. Dou y by dou phi is r sin theta cos phi. And dou z by dou r, z is this one, r cos theta. dou z by dou r is cos theta, dou z by dou theta is minus r sin theta, and dou z by dou phi is 0 because there is no phi term in z, and therefore r sin theta is constant, and therefore derivative of z partially with respect to phi is a 0. This one is constant as far as phi is concerned, and therefore derivative is 0. So therefore Jacobian of xyz with respect to r theta phi, we write it in terms of determinant xr x theta x phi, yr y theta y phi, zr z theta z phi. So put these values. Dou x by dou r is this one, dou x by dou theta is this one, dou x by dou phi is this one, dou y by dou r, dou y by dou theta, dou y by dou phi, dou z by dou r, dou z by dou theta, and dou z by dou phi, that is 0. So we put all these values in this determinant, and we simplify or expand this determinant, and the value comes out to be r square sin theta. So this you can add some more steps to evaluate this determinant and see whether the answer is r square sin theta. It is for homework. Next example is if y1 is x1 x3 by x2 x3 by x1, y2 is x1 x3 by x2, y3 is x1 x2 by x3. Show that Jacobian of y1 y2 y3 with respect to x1 x2 x3 is 4. So here from these y1 we find dou y1 by dou x1. So x2 x3 is constant, and 1 upon x1, derivative of 1 upon x1 is minus 1 upon x1 square. So dou y1 by dou x1 is minus x2 x3 by x1 square. Dou y1 by dou x2 is x3 by x1 is constant, and derivative of x2 is 1. Dou y1 by dou x3, x2 by x1 is constant, and derivative of x3 is 1. Similarly, dou y1 by dou x1, that is x3 by x1, x3 by x2. Dou y2 by dou x2 minus x1 x3 by x2 square. Dou y2 by dou x3, x1 by x2. Dou y3, next dou y3 by dou x1, that is x2 by x3. Dou y3 by dou x2, that is x1 by x3, and dou y3 by dou x3 minus x1 x2 divided by x3 square. So Jacobian of y1 y2 y3 with respect to x1 x2 x3 is this one, dou y1 by dou x1, dou y1 by dou x2, dou y1 by dou x3, dou y2 by dou x1, dou y2 by dou x2, dou y2 by dou x3, dou y3 by dou x1, dou y3 by dou x2, dou y3 by dou x3, and put these values. We have already obtained these values. Minus x2 x3 by x1 square, x3 by x1, x2 by x1, x3 by x2, minus x1 x3 by x2 square, x1 by x2, x2 by x3, x1 by x3, minus x1 x2 by minus x1 x2 by x3. So here we I have not skipped any step. All steps are here. So just simplification. First term is like this, second term is like this, third term is like this. So you try to solve this. Then this one is minus x1 by x3 minus x1 by x3 plus x2 by x1. Then minus x3 by x1 minus 2x1 by x3 plus x2 by x1, 2x1 by x2. So this becomes 2 because x3 gets cancelled, x1 gets cancelled, minus minus plus this 2. Then this one is 2 again, x2 gets cancelled, x1 gets cancelled, 2. 2 plus 2 is 4. So we have proved dou y1 y2 y3 divided by dou x1 x2 x3 is equal to 4. Then next example is, in the following cases show that dou xy by dou uv into dou u v by dou xy is equal to 1, or j into j dash is equal to 1. If j is this one, j dash is this one. If j is this one, j dash is this one, like this. So first example is x is equal to e raised to u cos v, y is equal to e raised to u sin v. So given x is this one, y is this one. So x and y are in terms of uv, and we have to obtain u and v in terms of x and y. So for that we square and add 1 and 2, and we get x square plus y square is equal to e raised to 2u cos square v plus e raised to 2u sin square v. So e raised to 2u is common, cos square v plus sin square v, that is e raised to 2u is x square plus y square, or 2u is log of x square plus y square, or u is half log of x square plus y square. So u in terms of xy is obtained like this. Give number 3, u equal to half log of x square plus y square. Now similarly we have to obtain v in terms of x and y. So for that we use the technique divide 2 by 1. So 2 by 1, RHS division, e raised to u sin v, e raised to u cos v, y by x, tan v is y by x. So v is equal to tan inverse of y by x, 4. Now we are having 4 equations. First two are are xy in terms of uv, and third and fourth gives uv in terms of xy. So we differentiate partially first and 2 with respect to u and v. So first equation we take and differentiate it partially with respect to u to get dou x by dou u is equal to e raised to u cos v. Similarly, differentiate it partially with respect to v, dou x by dou v is equal to derivative of cos v is sin v, e raised to u is constant, minus e raised to u sin v. Similarly, second equation we consider and we obtain dou y by dou u e raised to u sin v, dou y by dou v e raised to u cos v. Then now consider equations 3 and 4. So 3 is u equal to half log of x square plus y square. So dou u by dou x, differentiate that with respect to x. So dou u by dou x half into 1 upon x square plus y square into derivative of x square plus y square with respect to x, that is 2x. So that this 2 gets cancelled, x upon x square plus y square. Dou u by dou y half into 1 upon x square plus y square into 2y, that is y upon x square plus y square. Similarly, dou v by dou x is like this, and dou v by dou y, dou v by dou x, what is v? V is tan inverse of y by x. So dou v by dou x 1 upon 1 plus y square by x square into derivative of y by x with respect to x partially, so minus y by x square. So that this becomes x square comes here, that x square and this x square gets cancelled, and finally we will get minus y divided by x square plus y square as the value of dou v by dou x. Similarly, dou v by dou y is 1 upon 1 plus y square by x square, derivative of y by x with respect to y partially. So that is 1 upon x is constant and derivative of y is 1. So that finally we will get dou v by dou y as x upon x square plus y square. Why x? This x square comes here, x square and this x. So x remains here, and in the denominator x square plus y square. So now j, if we assume j as Jacobian of u v with respect to x y, then j is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Put the values of u, dou u by dou x, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, so that j comes out to be, expand this determinant and see the value of j is 1 upon x square plus y square. Then j dash automatically is the reverse Jacobian of xy with respect to uv. So dou x by dou u, dou x by dou v by dou x by dou u, dou x by dou v, and here it is wrong, dou y by dou u and dou y by dou v, dou y by dou v, dou y by dou u and dou y by dou v. So put these values, dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v, and expand this e raised to 2u cross multiplication cos square v plus e raised to 2u sin square v, that is e raised to 2u. But what is the value of e raised to 2u? E raised to 2u is x square plus y square. Put this value x square plus y square, and so that your j is 1 upon x square plus y square, j dash is x square plus y square, so that their product is 1. So j into j dash is equal to 1. That is proved. Next example is, if x is equal to uv, y is equal to u by v, then show that j into j dash is 1. So given x is equal to uv, so y is equal to u by v. From this means x and y are in terms of u and v. X and y are in terms of u and v. Actually, this example we will see in the next lecture, because try to understand all these things, because here the conversion is somewhat difficult. Means given x and y in terms of uv, and we have to convert uv in terms of xy. So that conversion is slightly difficult, and therefore I suppose for today it is sufficient, and then in the next lecture we see these again. So stay home, stay safe. Thank you very much.